Welcome, everyone. I'm Donato Clemente. A lot of y'all know me. Some of y'all may be new. Um, we are the Via Game developers, recently rebranded, middle of last semester. And we're going to be holding this sort of workshop, boot camp kind of thing going on for Unity to make sure that we make resources and we have things available so that people can get to learn how to develop with Unity, how to get into Unity and start working with it so that we can, at the very least, have a baseline level for people to get interested into game development, get their feet wet with game development and see if they're into it or not. And for the people that don't show up to these meetings, they get to see the video recordings, and hopefully we can enrich their student experience here at UTRGV by offering those kinds of resources to them. And really our entire mission is to push forward game development here at UTRGV as hard and fast as possible with the limited staff that we have. We're a volunteer group, as are all student organizations, so we're really putting our all into making sure that we can do the most that we can to get game development rolling here at the university. Right, so let's get started. So we have here our first summer workshop for Unity. This is going to be a series that we'll have 4 different workshops for, and we'll be going over character controllers specifically in this workshop. We'll be following up with collision detection and exiting management. And then after that, we're going to get into enemy management, health, attacks, and hitboxes. And after that, we're going to be getting into scene management, UI, and button inputs so that we can have a well-rounded base so that people can really just, hop in and get started with Unity. They need a hand, I'll be here to help. Anybody has questions, this will be rather involved, and I will be taking you guys step by step as we go on. But yeah, any questions, feel free to unmute and hit me up at any point in time, or use the chat as well. So our agenda today, very simple, although not really, but for the presentation here that I have on PowerPoint, I'll be going over the requirements to get started right now and move on to the workshop content. So right now for the requirements, you have to have Unity installed. So Unity has a bunch of different licenses for businesses, indies, hobbyists, students, and they offer a free of charge license that you can use up until a certain amount of income. I forget what the exact number is, but for the most part, unless you're going to be making a bunch of money off of your Unity projects, you can start off with the free licenses. And if you're a student at UTRGV, you can go ahead and apply for the student license, which gives you access to certain resources and assets that you can use. You can get into the specifics of it by going to unity.com, the website, and give it a look, see what kind of resources you can get as a student. But for the most part, all we really want and care about is getting access to the editor, which is the bread and butter. It's where everything resides, and it's what we want to be using actively to build everything because it's such a unique and useful tool. These full shop game editors that come with literally everything you can think of, and if it doesn't have extensibility for it, you can just build it in C#. So yeah, make sure you have Unity installed first and foremost. Second, I'm gonna ask you guys to go ahead and download a couple of assets from the link that you see there, bit.ly/Unity Summer 1. It's gonna have a sprite sheet and a couple of backgrounds that you guys can use when building the project that we're going to be getting into. Let's move on to the next part, which is just straight up workshop time. All right, so if you have Unity installed, you should be able to see this Unity Hub over here. I want to go ahead and start it up. And Unity Hub is the place where you manage all of your Unity installs. So if I go over here to installs, you'll see I have a couple of different long-term support versions and a couple of recent builds that's not categorized as super safe. But for today, I'm going to be using the most recent long-term support version of Unity that's out right now. 2022.3.2f1. It won't really matter what version of Unity you guys have downloaded, because it should be, universal for the most part. It's plain C sharp, and the libraries haven't changed too much over the years. You should be good, whatever version of Unity you're rocking right now. So let's go over to projects. Gonna go ahead and make a new project. I'm gonna be using the 2D core template that Unity comes with. And I'm gonna go ahead and call it something I'll remember. And I'm gonna go ahead and create the project. Yeah, that should run for a little bit. And if you guys have any questions, any issues, let me know. Oop. There we go. So if all went well, you should hopefully end up seeing something that looks like this. To get your bearings, what's going on here, we have a hierarchy tab over here. And this essentially tells you what's going on, what you're looking at, what stuff made out of. Because Unity is built based on scenes, which are objects that hold other objects. So it's like, I guess a scene could be like a level where everything inside of a certain level is contained to itself. So there's certain kinds of pickups, certain coins, you make certain progress in a level. All of that can be saved inside of a scene. Things inside of a scene can also be thought of in the same way, where they're built up of different components. Down here is where we have all of our assets. So when you make a new project in Unity, it creates a folder. And in that folder, there's a assets folder. And this is what we're looking at right now. If you look over here, there's a bunch of other folders and stuff that we can look at. And that's all going to be inside of the generated files for your Unity project. On the right-hand side, we have the inspector, which is going to tell you more in-depth information about whatever you have selected in the hierarchy. So if I go ahead and click on the camera, you'll see that a name, tags, layers, transform information is popped up for it. And also this camera component, which has been added to the object over here, is what makes it act like a camera and gives it all the functionality of being a camera. So if I were to remove the component, we would no longer have a camera inside of the scene, and we wouldn't be able to see anything drawn or rendered. But I'm not going to mess with that for now. What we're looking at in the middle is essentially the scene. It's what's visually happening inside of the scene. So here we have, as you can see, there's some tabs over here, scene and game. So this shows visually what's going on in a scene. This game tab essentially shows what's going to be rendered when we start running the actual game. But for now, we're just going to be working inside of this scene tab. So don't worry about that too much. First things first, we're going to pop up the assets that we downloaded earlier. These are the assets right here. So I'm just going to go ahead and drag and drop them into the Unity assets folder right here. And everything should get properly added. Oh, it should be 4. I accidentally added something else from my downloads folder. There it is. So once we have them in here, we're going to completely ignore them and move over here to the scene to start putting stuff in here. First things first, as I mentioned for the main camera, everything inside of Unity is a game object. So we're going to go ahead and add a new game object here. So we click on the little plus icon over here, far left, and you should see something to create empty child. And it'll immediately put you into the ability to give it a name. I'm going to go ahead and name mine player, since we're focusing on making a player controller today. And you'll notice that there's a lot of similarities between this new game object that only has transform data and the main camera that we were looking at before. And that's because, as I mentioned, all game objects are pretty much the same across Unity, and the only thing that makes this game object that's titled main camera work like a camera is this camera component. And we add components to game objects in order to flesh them out give them more abilities, and give them more functionality, as we'll see here in a bit. So click back to your player game object, and we're going to go ahead and add a component. So first things first, as with anything, we want our player to exist in the world as a physics object. So we're going to go ahead and add a rigid body 2D component to the player game object. So there's a couple of things I want to change here. So first things first is to remove the gravity scale, because we're going to be making a top-down player controller. So the gravity is in the Z direction, but we're not going to be focusing too much on being able to fall or jump. So we want to zero out the gravity so that it's not able to fall. And under constraints over here, we want to make sure that it can't rotate on the Z axis. And that's really just a safety precaution. If you're not adding rotation on the Z axis, it's not going to add rotation magically. But sometimes if you're working with a quaternion rotation, weird stuff can happen. So it's best to just make sure that it just can't happen at all. All right. Once we've changed gravity to 0, frozen rotation on the Z axis, we're going to go ahead and create our script for the player. So if you go ahead right here inside of assets, you can right click and hover over here to create, and you'll see a bunch of different stuff. These are different things that we can create in Unity, different kinds of file types and game object types that we can use to construct and flesh out our scenes. But we're focused and interested in this C# script over here. So going to go ahead and click on it and name the script player controller. You can go ahead and name it whatever you like. Same with the game object. But I don't want to get too confused, so I like to name everything in a certain way. So now what we're going to do, we're going to add this player controller script to our player game object as a component. So if we go right here in the search, you should be able to type in the name of your script and you'll be able to find it. So now we can use this script to directly manipulate whatever's inside of this game object. And that's what we're going to do. So you can feel free to use whatever editor you prefer for coding. The one that comes by default with Unity is Visual Studio. But for the most part, if everything's going well and everything went well in your install, you should be able to double click the player controller and open up Visual Studio. All right. So I have a script open here. First things first, we want to get a couple of variables down. So we want to be able to reference the rigid body to be able to apply velocity to it. The rigid body already calculates and manipulates most of what's happening inside of the physics simulation. So we want to use it instead of force feeding it our own physics calculations. Of course, you're free to do so, but for this specific workshop, we're going to be using rigid body 2Ds. Do not have to do that on our own. So I just want to have a reference to it. I'm going to have an empty variable here with the type of rigid body 2D. And for any character controller, really, you want to have some kind of ability to manipulate the speed of the character controller. So in C#, we're going to be using floats here. Max speed. And I'm going to go ahead and set it to 8, because when I was testing, 8 worked well for me, but we'll see if that remains true. Next thing, we want to go ahead and have a couple of vector 2s. I know most computer science majors should be rather acquainted with vector mathematics, but essentially it's like looking at a graph, certain amount of movement in the x-axis, certain amount of movement in the y-axis, and the z-axis to have 3 dimensions. But we're going to want to define vector 2s, so x and y. So we're going to want a vector 2 for inputs. So we can manage inputs and keep them in a vector 2 format. And we're also going to want one for velocity. And that's what we're going to be force feeding to the rigid body. Well, I think I should probably explain what these predefined functions mean. So in game development and generally in development, you're going to have a clock. Computers operate on a function of cycles. So each cycle, things happen, and these cycles are defined by the hardware that these computers are built with. But in game development, we also manage these cycles as well. But these cycles are in order to manage frame rate and the fidelity of your physics simulation, because you don't want to, calculate all the mathematics for your physics constantly. That would tax the computer for no reason and, fill up all of the computer's ability to do anything. And it would make a pretty bad game. So instead, we use clocks and cycles in order to be able to process physics in a timely manner, because computers are able to do stuff at insanely fast speeds. And in Unity and most game engines, you're able to have access to those loops. And this update function right here is an example of one of those loops. So anything we put inside of the update function is going to get called every frame. There's also a function called fixed update. And this one happens every physics clock tick. So anything that needs to be high fidelity physics related, put it in fixed update. Anything that doesn't, you can put it in update. Stuff inside of the start function, whatever we put inside of it gets run once. So whenever our player is loaded into the scene, when the game starts up, anything inside of here is going to get run once. So we're going to use that and take advantage of it to go ahead and put the rigid body 2D reference inside of this variable. And the way we do that is by calling get component. So as I mentioned before, game objects have components. They're made up of them. And this is how we would access it. Get component, rigid body 2D. But I called that without actually setting it to anything. So going to go ahead and shove it inside of the body variable. And that should square away getting the reference to the rigid body 2D inside of the player game object. So now we can reference this variable inside of our update. Whenever we have a player controller, we want to make sure that we're processing the inputs from the player. So Unity by default, if we go back to the editor, that's not the editor. Let me go ahead and close that. By default, we hop in over to here, over to edit, project settings. Woo. There should be something here for input management. There you go. I'm already here. And then if we open up the axes, you'll notice that there's different labels, and these labels, horizontal, for example, has negative and positive. So left, right, AD, if you're using WASD, we are able to manage input management from here. Since it's already defining horizontal axes, vertical axes, we don't need to worry about it too much. If you're using some fun controls, there are different ways to read those kinds of inputs. So for example, if we wanted to see whether or not a certain key is getting pressed, we can go ahead and type in input dot get button. Get button checks if it's being held down, versus get button up, which checks when you've released the button, and get button down, which checks when you've pressed it. Of course, that's for buttons. We'd be looking at keys. So if you had a specific key you wanted to put in, for instance, the E key, we can go ahead and look for the Unity variable for it, because each key has a certain number related with it on your keyboard, but Unity has it all packaged away nicely in variables. So if you wanted to get access to whether or not E is being held down, that's how you would do it. but we're more interested in abusing the ability that Unity gives us than having these axes variables already detailed. So we're going to go ahead and call the inputs variable that we defined over here. And we're going to make a new vector 2. And inside of here, we're going to have an X and a Y axis, but we're going to define those different axes by using the getAxis function from the input class. So input dot getAxis. And I went back and showed you guys that there was like a bunch of different names because right here it demands that you give it a name. So I'm going to call horizontal, the horizontal axis for the x-axis. And for the y-axis, we're going to get the vertical axis. Sure to put the semicolons in. So essentially what we've done here is we've set inputs to be a vector where the x-axis is going to be defined by the inputs that Unity detects for horizontal, and the y defined by the inputs that Unity detects for vertical, as defined inside of the preferences. And you can set those to whatever you want. If you want to use these axes for different keys, more than free to do so. But for my purposes and the purposes of this workshop, WASD and left and right arrow keys should work just fine. So next thing we want to do is we want to calculate the velocity from these inputs. Whatever vector that we're getting from the inputs, we want to turn it directly into movement. And all you have to do really is apply a certain amount of difference. So a delta, so for the delta, we're going to be using our max speed over here. And because we're using a rigid body 2D, we don't have to do too much math as far as that goes. We just go ahead and set the rigid body 2D's velocity to the velocity that we've calculated, and it'll move accordingly. So having said that, let's go ahead and define our new velocity. So we're going to be accessing the vector2 class directly. Whoa, what did I type? And we're going to want to use a function inside of vector2 called clamp magnitude. So this is more so just to make sure that our velocity doesn't exceed the max speed. As for why we're doing that and not just letting chaos take over, it's more just of a control mechanism. So it just makes the experience a bit more cohesive by making sure that no matter what direction you're moving in, you're going at the speed you should be. So first things first, we want to go ahead and multiply the inputs that we got earlier by our max speed. And that's gonna, it's gonna make it so that our inputs, which is each axis, maxes out at 1. So if we wanted to go to a little faster, we just multiply it by a certain number. And then we go ahead and set a maximum length for the magnitude of the vector, which will also be max speed. And from here, we've defined almost everything that we need to start seeing something going on. But now all we need to do is apply this velocity that we've created here to the rigid body 2D. We've set it over here in start, so now we're able to use it down here. And the reason I'm putting the velocity change inside of fixed update is so that it processes inside of the physics process. Because if you do it every frame, it's different from doing it every time that the physics are getting updated. If you're not applying your velocity during the physics updates, when you're also doing collisions or you're doing impulses, pushing the player around, then things get kind of weird. And all we have to do that is go ahead and call the body variable that we set earlier, grab its velocity, and force set it to our velocity variable. And by doing that, suddenly everything's good. So I probably didn't explain that in the best manner. So any questions, comments, concerns?
Out of curiosity, how come you don't set the physics vectors just in the fixed update loop? it seems like you're setting the actual physics vectors every frame, even though you're only using them every tick.
That is fair. Yeah, there wouldn't be any real issue. Um, I guess I would just need to do my homework and check again. Mm, yeah, okay. Anyone else? Other questions on just this part? Okay, so now we have everything set up here. Make sure to save your script so that nothing terrible happens. We can go ahead and this isn't going to show us anything, but the player should be able to move now. So for testing purposes, let's go ahead and add a component. So if you go ahead and search sprite and then click on sprite render, it should go ahead and add the component to your player game object. And then from there, we want to add something to it so that it actually shows. So right now it says none sprite, but we want to add something in there. So we click this little dot next to it to open up the Unity base assets. And then from here, go ahead and click on one of these. The background sprite should be good, but there are different sprites if you just want to play around with them. But if we zoom in here, you'll see that there's now something there. And because everything's going to be so small and pixelated, clicked over here on the main camera. And under the camera component, I went ahead and went to size and set it to 0.7. That way we're really zoomed in and can just, see our little dude move around. So now we should be nice and zoomed in on this funky little sprite. And if we go up here and click on this play button, it'll run our sample scene inside of the game editor. So you notice it switches over to the game tab. And now if we give it some kind of input, ooh, we're zooming. But yeah, if you use WASD or the arrow keys, you'll notice you'll be able to move your person around. Yeah, for me, it's a little too zoomy. So I'm definitely going to go back to the script and change it. Where's Visual Studio? Here we are. So I'm going to go ahead and make this variable public. So what this is going to do is it's going to allow it to be shown inside of the editor. So we can go ahead and manipulate and mess with it within the editor instead of having to go back to the script, reload everything. Go back to the script, change it, reload everything, and then run the game again. So now instead from here, I could go ahead and set the max speed to 5. Oop. Run the game runtime again. And now I should move a little less sporadically. It's still pretty fast, but I think that's all right. And you guys go ahead and feel free to change the max speed to whatever you feel is necessary. And again, the only thing I did was set the variable to public so that it would be displayed inside of the editor. So now that we have our player controller all moving around and doing stuff, we can go ahead and start moving into the animation and the sprite sheet for this person. So if you click on the Vaquero image, you'll see a bunch of different properties of the way that the image is imported into Unity. So we're going to want to set this sprite mode over here from single to multiple because we're going to be having multiple images within the same image. Pixels per unit, we're going to want to set it to 16 since each of our individual units will be 16 by 16. And then going down, you're going to see filter mode. We want to set it from bilinear to point so that there's no fuzzy edges with our pixel art. And the last bit to make sure that the pixels are nice and crisp is to go down to compression over here and change it from normal quality to none. So once you've got all those guys figured out, you can click apply and it'll re-import the image with these settings. And we can move on to defining the different different sprites within the sprite sheet. So we move over here to the top area of the inspector for the image. There's this button with sprite editor on it. And we want to click on that bad boy. And this window should pop up for you. And what we're going to want to do is click over here where it says sprite editor. Oh, no, not there. We're going to want to click where it says slice. And we're going to want to change it from the automatic type to grid by cell size so that we can define the specific cells of the sprite sheet. And as I mentioned before, these guys are going to be 16 by 16. And you'll notice that the red lines line up pretty well with where the different frames of these animations are going to be. And once you put in grid by cell size, 16 by 16, all we need to do is go ahead and hit the button for slice. And those slices will stay the way they are. So feel free to exit out of the sprite editor, I think. Let's see. Okay, yeah, it'll ask you to save it. We have to save it first. And we should be good. So now if you'll notice over here, in the Vaquero asset, there's going to be a little right button, and there's going to be all of our different sprites labeled by their names. So now we can move forward with making animations using these different sprites from the bigger sprite sheet. Okay, so now we're finally going to start jumping into some animation stuff. So I'm going to go ahead and right click here in assets and move up to create. And at the very top, there'll be the option for a folder. So I'm going to go ahead and create a folder. Call it, excuse me, call it animations. And I'm making a folder just to be able to keep everything nice and neat in the main assets folder, because we are going to be making a few animations and also an animation controller. So just to, keep the main folder nice and clean and not have a bunch of animations rolling around, we'll go ahead and put them inside of this folder. So to add animations to a game object, let's go ahead and hop back over here to the player game object. Back to scene, player. To add animations to game objects, you're going to be adding another component to them. And this component is called the animator. So, yeah, rather basic. We feed it an animation controller, and the animation controller will have access to different animations. So while we're here, we want to go ahead and switch out the current sprite that we have for our player. So get rid of that. And we want to set it, I want to go ahead and set it to our current Vaquero sprite sheet. So you can just go ahead and you can't click on the Vaquero because then it'll switch the inspector over to the actual image. But if we drag and drop it, we can just shove it into the sprite value for the sprite render. Or alternatively, I think we saw it over here. The sprites have made themselves available after we did the slicing. So you can go ahead and just click Vaquero 0 and it'll populate him right here. Okay, so now that we have an animator and a sprite render with the sprites inside of them so that we can access it, we need to make a animator controller. And I'm just going to go ahead and call it Vaquero animator. And if we click back on player, under the animator component, we can go ahead and drag the controller into there, or you can click the circle and it should populate in there, and you can just double click to have it in there. So I went about this a bit incorrectly. Let's go ahead and destroy that first animation we made. So you should have the animation window open now. And if we click on our player, because it has an animator and animator controller, we can now make an animation within the animation window. So if we hit create, there we go. It'll ask us to give it a name, and this will be what I input last time. Oop, typo there. Idle down, and it's going to get saved into the animations folder. That's correct. So now we should finally have access to the sprite. And if we go back to the assets folder, you'll notice here the idle down animation is currently selected inside of the animation window. So now we should be able to just drag and drop the first frame into here. And you'll notice that a little blue dot comes up, and that's our key currently. The first frame, first key for this animation. And you'll see this drop down arrow right here, and we can actually see the image there. So yeah, okay. So first 4 images are gonna be the idle down animation. So I already put in the first image right there. So gonna put the second image at 0.1, third image at 0.2, fourth image at 0.3, and then for the animation to loop properly, we want to put the first one, the first frame at the end so that it's the same when it starts and when it ends, and it'll be a nice loop. So there's 2 ways you can do this. You can go ahead and redrag the first frame to the 0.4 mark, or you can click on the first frame, copy, and then wherever this timeline bar is, so if we move it to 0.4, click on the first frame, copy, and then whenever we paste, it'll drop it to wherever the timeline bar is. So that way, if we're like really deep into the sprite sheet, you're not sure exactly which one was the first frame, you can always just copy paste it there. But yeah, that's the first animation done. So if we were to drag this guy back down and press play, you'll see that the vaquero stops hopping up and down, little hat moving around. Yeah. That was a little confusing on my part, because I forgot how to do it. But any questions, let me know. And from here, it's just the grueling task of doing this over and over again, so that you make all of your animations from the sprite sheet. So for instance, let me drag the animation window back up here. We'd click right here on the drop down. How to get to the animator? Yeah, for sure. Well, to the animation window, this specific thing. Okay, cool. So let me go ahead and close it. The correct way to get to it would be to go ahead and click on window up here, go to animation, and then click on animation, and it'll pop up. Yeah, no problem. And then to actually see the different animations, you have to click on the game object that has an animator, and then it'll populate the animation, and you can play it, mess around with the actual animation as well. But this guy's free floating, so let me put it back up there. And okay, so we have the idle facing down. Let's make a new animation. Idle up. And unfortunately, I didn't have the foresight to properly arrange all of the different sprites in a way that would make sense. So instead, let's see here. If we look at the last few frames of animation, these last 4 are for walking up. So then the 4 before it must be for idling up. So we can go ahead and grab this guy, put it at this first frame. This one, put it at 0.1. This one at 0.2. This one at 0.3. And then copy the first one to 0.4 so that it loops. So now if we go ahead and play this animation, move back to the scene. Oop, can we not do that at the same time? Oh no, it's probably because I have that frame selected. Nope, that's not why. There we go. Okay, yeah. Needs to be in a different area for you to be able to play the animation and see it in action. Yeah, so we now have the idle in the up direction working as well. And you can, switch between the animations here inside of the animator just to make sure that the animation looks the way it should be. So we have idle up, idle down. So now we're going to need another idle animation for the horizontal axis. Because you can use the same animation going left to right. You just need to flip it. And that's what we're doing here to save on needing to make, 4 animations for every direction. So I'm going to go ahead and call this one idle X for the X axis. And let's see here. So these right facing ones will be it. The last 4 are for walking. The first 4 are for idling. So gonna go ahead and drag the first one in, the second one to 0.1, the third one to 0.2, and the fourth one to 0.3. And then we can go ahead and copy paste the first one to 0.4. And it's kind of annoying having to move the animation window every time I want to see an animation. But now if we hit play, there we go. So now that we have those 3, we can move on to the walking ones for the same up, down, and X. So we'll make a new one. I'm going to go ahead and call this one walk down. Grab the first one. So again, the first 4 facing towards us are idle. The second 4 are the walking. Walk up. First 4 are idle, second 4 are walking. I just zoom through these. And walking in the x-axis. This guy. Sideways. First 4 are idle. Other ones are walking. All right. Now that I have them all in place, we can go ahead and test them out. So walk X, walk up, and walk down. I'm not sure if the next portion is going to be any easier, but we're going to get into animation trees. That's fun. Okay. Well, specifically the animation controller. We created it earlier, shoved it inside of the animator. So now we can go ahead and close out of the animator window. Let me go ahead and package the Vaquero sprites back in. And so over here, the player, game object, animator component, can go ahead and double click on the Vaquero animator, and you will find the animator controller for the Vaqueros animator. So you'll notice as we created all of our animations, they were automatically added in here. So a little bit more context. This is a node editor. You tend to find these in all kinds of situations, especially with any kind of like UI based logic management. Lots of game engines use it for animation, for state machines. I'm pretty sure Unreal's blueprints are very similar to node-based UI. But you'll notice all of our animations got shoved in here as nodes. So they're just little visual things that we can click on and drag around inside of this endless void grid. And when you click on something in the inspector, it'll have properties like everything else. And for the most part, we don't need to worry too much about the individual properties because we're going to go ahead and nuke all of these animations from the get-go. So I control clicked all of them and then I pressed delete. That got rid of them. So let's explain these nodes that come prepackaged. When your game object has an animator on it, as soon as the game object gets rendered, this entry node is what gets called, and whatever it's pointing to is the animation that gets played or the logic that gets processed. You can connect any of these nodes to something by right-clicking and then clicking on Make Transition, and notice how it snaps to the different nodes here. And the exit node, you transition from another node to the exit node if you no longer want anything to happen. But for our intents here, we're only going to be focusing on the entry node. So currently it's pointing to our idle down animation. And what that means is if we were to go ahead and go into play mode, let's see here, hopefully this works. Yeah, we go into play mode, idle animation, idle down specifically, will be playing because on entry, that's what's supposed to happen. But that's not really what we want. We want to be able to process input and change animation state based on input. So in order to do that, we need to do a couple things. First, we need to exit play mode. So over here inside of the animator, you'll notice these tabs. There's one for layers and one for parameters. We want to click over to parameters, and this is where we can create essentially variables for the animator to hold that we can then set through code. And that's what we plan on doing. First things first, we click this plus, and we want to add 3 different float parameters. So the first one, we're going to go ahead and call it horizontal. Second one, vertical. And the last one, will be speed. So you can call these whatever you want to, make more sense to you. X-axis, Y-axis, velocity. But for my setup, I'm going to do horizontal, vertical, and speed. So once we have those parameters, we can now start doing some fun stuff in here. First things first is getting rid of that connection that we have here. Well, let's get rid of the animation. So now that we have a free floating entry state, let's go over here and right click in an empty area and hover over create state. And we're going to be wanting to create a blend tree to be able to process different axes at the same time. Notice once we added it, it automatically set itself to be the first thing that happens. Entry will automatically attach to something. So this is going to be our idle blend tree. Call it idle. And if we double click on it, we'll open up into a new node thing. The whole point of a blend tree is to be able to blend different values. So as you'll see here in this node, we have it in currently a one-dimensional blend type, and its current parameter is the horizontal value. So we want to be able to process both the horizontal and the vertical values in order to define whether the up, down, or x-axis animation is getting played. So all we have to do is go over here to where it says blend tree and change the blend type from 1D to 2D simple directional. There are other types, but simple directional will work for us. So first parameter, horizontal. Second parameter, go ahead and set it to vertical. And nothing shows up yet because we haven't added any specific variables to mess around with. We have two parameters for our blend tree, and we want to add some motion stuff. So to add stuff to this list, all we have to do is press this plus button, and it'll ask you if you want to add a motion field or a blend tree. So a blend tree we would essentially be adding another one of these inside of it. And that's not exactly what we're looking for. We want to add a field to the blend tree to be able to, control what happens when we get a certain kind of value on the horizontal and vertical axes. So if we go ahead and add a motion field, nothing much happens, but we're going to need 4 for the different directions. So that'll be our up. Going to need another one for our down, and you'll notice that this graph shows up. And it'll start doing stuff once we add our third and the fourth one. So we want to go ahead and make sure that each one of these motion fields aligns with a direction that we want to have an animation play at. So for the first one, if we want to set it to up, so that's 0 on the x-axis and 1 on the y-axis. And then we go over here and add the animation for idle up specifically, because this is going to be our idle blend tree. Let me go ahead and change the name just to make it more, explainable. And then for the down, it's just going to be 0 on the x, -1 on the y. And idle down will be what goes there. And then the next one, well, the next two will be both idle x. And it'll be 1 on the x, 0 on the y, and -1 on the x, 0 on the y to catch both left and right. And you'll notice as I move through the 4 different ones, it'll highlight it's a sphere of influence on the graph, essentially. We're essentially going to clone this, make an exact copy of it for the walk one, and then we'll make some transitions. But any questions on setting this up specifically? Yeah, if there are no questions on this specific aspect of it, we can go back to the base layer and make another one. So again, right click, empty space, create a state from a blend tree, Actually, I wonder. Oh, we can copy them. Wait, hold on. Let's go ahead and copy and then paste a. Okay. So now I have a second one, and we're going to call this walk. So the only thing that's going to change, double click to go into the walk blend tree. The only thing that's going to change, click on the idle blend tree, is that now instead of idle up, they're going to be doing walk up. Instead of idle down, walk down. Instead of idle X, walk X. So now that we have different fields for the idle one and for the walk one, all we have to do now is set logic for the idle one to move to walk and for the walk one to move to idle. So if we go ahead and select the idle node, right click, and then go ahead and hit make transition, there'll be this arrow thing that showed up earlier when I was messing around with the any state. And in order to make a transition from the idle to the walk node, all you got to do is go ahead and click on the walk node. And now we have a transition from idle to walk. If we click on the transition specifically, the arrow will become blue. You'll see that there's conditions, and we can set a condition for the transition to happen. And what we want, you'll notice that when we click the plus, it'll set up this condition list item, and it'll auto-populate the first one with the parameters that we set up earlier. So horizontal, vertical speed. And to move from idle to walk, we want to make it so that our speed, if it's greater than a rather small amount, so 0.01, if our speed's greater than 0.01, we wanted to move from idle over to walk. Because our animations are rather small and limited, we want to do some adjustments to the actual transition, because you'll notice that there's a smooth transition here in this graph. And usually for like 3D animations, there's a bunch of things like moving at the same time. So if you don't have any form of smoothing or tweening going on, it's going to look rather jarring. But for our rather simple pixel sprite situation, we don't need any form of transition. Instead, it'll just like delay the different transitions and it'll look a little weird. So gonna go ahead and uncheck this box that says has exit time to remove the exit time. And in the settings for the transition, we want to make sure that the transition duration is set to 0. And you'll notice that it goes idle blue and immediately goes down to walk instead of what it was before. And yeah, that's one transition set up. And the transition back to idle will be exactly the same thing, but instead of speed greater than a certain amount, you want to check if speed is less than a certain amount. Okay, so we made our first transition from idle to walk, and the condition is that the speed has to be greater than a certain amount to trigger the change from idle to walk. And now we want to move back. So this time selecting walk, we want to make a transition from walk back to idle. And we need to go ahead and edit the transition the same way we did with the other one. Go down here, add a condition, make it so that the condition is if speed is less than 0.01, it'll go from walking back to idle. And then let's go ahead and turn off has exit time and change the transition duration to 0. And that is all the logic you need for this simple character controller. From here, it's all code. So moving back to our code, and well, I have Visual Studio already open, so I'll just open that. Okay, so now we want to get access to our animator. So up here where rigid body 2D is, we want to have a reference to our animator. So of type animator. There it is. I'm just gonna go for what it gave me, call it animator. So now I have the variable, we can stuff it in inside of the start initialization. Oh, there's the autocomplete. I'm going at it. Inside of the start initializer, go ahead and set the animator variable to get component animator. And then from there, we can do all of our animation stuff inside of the update function. So from here, we want to get access to the parameters that we created inside of the animator and set them to certain values. Because once we set them to values, things will start changing automatically because we already set up the logic inside of the blend trees and with the transitions. So let's go ahead and call our animator variable. I believe it is based on the specific kind of variable that you set. So if we go back to our animator, our different parameters, well, all our parameters were of type float. So we need to go ahead and set float. And then inside of the set float function, we give it a name. Well, the specific name of the parameter we're looking for. So in this case, we want to get horizontal. And comma, the second parameter for this function will be the value we're going to feed it. So for our specific situation, we want to feed it the x velocity, or rather the input. The input values already go from -1 to 1, so that checks out. For animator, set float vertical, same thing, but instead the input will be the y-axis of our inputs. And the last one will be our speed. Animator dot set float speed. And the value that we're going to be feeding speed is going to be the magnitude of our velocity vector. We go ahead and type in velocity. It's of type vector 2, and it knows that. So we can go ahead and type dot magnitude autocomplete, and that'll give us the float value of the vector. And from there, I think we should be good to actually see some animations working. So I'm going to go ahead and press save. And then move over to our game scene. So our little pixel dude's a bit big in the camera. So I'm going to make the size, it's still too, yeah, we'll give it like a 3 for the size in the camera. Make sure to save your scene. So if Unity crashes, you don't lose anything. It'll show a little asterisk if it's not saved over here near sample scene. So let's go ahead and hit play, see if this works. So first test will be to see if it goes straight into idle. Yes, it does. Notice how it went straight to the up idle animation. And that's because inside of our animator, we go back to the the blend tree. The first animation here is idle up. So that's why I went straight there. For my personal reasons, I want to make it so that it's idle down. And so I'm gonna just switch those up. That means that the first one has to be y-1 and the second one has to be y1 instead. So I just quickly made those changes, hop back into the game. Still happens in the runtime. Okay, so now that we have that, let's give it some inputs. Hey, okay, so x-axis, since we only have one x-axis animation, whether we're moving left or right, it'll be that x-axis animation. But let's try moving up and down. Nice. All right. Working decently well. But let's fix that x-axis. So to fix the x-axis animation for our little guy, in order to make it so that our sprite flips whenever we're moving left instead of right, all we have to do is go ahead and run a check on our inputs. So if our inputs on the x-axis is less than 0, we can go ahead and do it inline here, since it's not going to be a multi-line conditional. If inputs.x is less than 0, then we want to specifically grab the sprite renderer. So we're going to be using the same thing we used in the start function, get component, because we want to have the sprite specifically flip on the x-axis. And so we want to grab the sprite component to do that. Sprite render, there we go. And the sprite render has a built-in function called flipx. Well, not built-in function, but built-in value variable that we can use. There it is, flipx. And we can set it to true. Oop, it's my dog. We can set it to true, and that'll flip the x whenever x is less than 0. And that's great. But it'll stay stuck if we don't put an else there. So when it's not less than 0, we want to switch it back. So get component, sprite render, flip, no, not y, flip x, and set it back to false. Go ahead and save the script, hop back into the editor, wait for it to reload. There we go. And if I hit play, we should hopefully see it move left. There we go. So there's one final sin that's happening here in the animation controller that I'd like to rectify before closing up shop. You'll notice once you stop giving it input, it defaults to the idle down no matter what direction you were originally going in, which nullifies, 3 animations that you set up. And the whole point of having idle animations in different directions is because you want to see them. Yeah, we're missing 3 lovely animations that we worked hard shoving into animations that are not showing themselves because it's constantly defaulting to idle. And the reason for that is because when we set our horizontal and vertical, let me go ahead and drop this down here so we can see both of them at the same time. Go back to the base layer. So notice how, because our inputs are based on the keys that we're clicking, the more pressed down the key is, the closer it gets to the 1 value. So if it's not pressed down at all, the direction doesn't stay saved. So it'll default to 0, 0. And the default of 0, 0 is the first animation. And right now it's idle down for me, idle up for you if you guys didn't switch it. But we don't want that. We want to see our idle animations. So essentially all we have to do now to be able to have the direction stay saved when our inputs are no longer in existence, because when we let go of the key, it zeroes out and that goes to the default. What we're going to do is we're going to add a new variable to keep the value of the direction that's being pressed before it disappears. So we're going to go ahead and call this vector2 direction. So yeah, just pop it down there. And we're going to hop back to the update function since we're processing all of our animation stuff here. Let me go ahead and make some comments. Oops. There we go. Just to clearly define that. And what we're going to want to do is set the direction if the input's magnitude is not equal to 0. So let me turn that into code. If inputs.magnitude is greater than 0, because we don't want to set a 0 value, otherwise that defeats the purpose of saving a direction. So if it's not 0, we want to save the inputs as our direction, but we want to normalize the input vector. Normalized. So what normalizing does is essentially it gets the ratio between the x and the y, specifically here because it's a vector 2, x and y. It gets the ratio between them and it limits the value so that the magnitude is 1. So, and that's convenient for us because our horizontal and vertical axes work the same way. So it's just a convenient way to save direction as a value of 0 of -1 to 1. And yeah, just rather convenient that we can just, normalize our vector for inputs before it hits 0, and it'll still be just as valid as if it were at full force because it normalizes to 1. So now that we have our direction saved and it doesn't zero out, therefore defaulting back to the idle state that we were looking at before, we can go ahead and change the value for horizontal and vertical from inputs.x to direction.x for horizontal, and for vertical from inputs.y to direction.y. And we also want to switch out the inputs over here for the flip to direction. Both of them work the same way, but just to keep it all clean and concise using the same variable. And yeah, now that the direction never zeroes out due to not having any pressed keys, we should keep the direction in place for the idle variable. I mean, the idle animations. And we can see the idle animations in the different directions. So any questions on that? A lot of explanation for just a variable and changing a couple things. Okay. All right. This is the last bit. We're almost done here. Let's see. Okay. So now if I were to give it input, there we go. It saved the direction because it never zeroes out due to the input. And we can see our glorious idle animation for the x-axis. And flipping should show the same animation. Going down should show us the one we've been looking at this whole time. Then going up will give us the top one. All right. Now you should have a little buddy that idles in the direction that you're moving, moves around. It'll interact with collisions once we do that workshop next week. But yeah, that's it from me. Appreciate y'all for hanging with me a whole 30 minutes after the scheduled end time. Appreciate it. But yeah, again, if you weren't able to follow along too well in real time, I'm going to post this up, cut up the, irrelevant bits, and post it on YouTube. I should have it over the weekend. If not, ping me, remind me. Because right after this, I have to hop on something else. But I appreciate y'all. Thank you for coming. And that's it for me.